Good morning. Did you get my announcement yesterday? So if you didn't read it, then read it. And I made a short video clip about second exam and how to prepare for the second exam. The one of the important thing I talked about was the submission pattern. If you already started the quiz, then maybe you notice that the submission pattern has changed. In homework and last test, you had to submit each question. This time, in quiz setting, I changed the quiz setting so that you can you just turn in once after you're done with that. The submission button will appear on the bottom. When you type your answer on the empty box, the website will start to remember what you typed. So there is an automatic save feature. So the website will just save your answer, and then you worked out the other problems, and then want to go back to the previous problem and want to fix the problem because you felt like you didn't do it correctly. And so you change the answer, then website will save that answer also. That will save all the typed answers, but what will be graded will be the last saved answer when you submit the entire things. Okay. And if you don't submit the entire thing and try to close the browser, then I heard that there will be a warning pop-up message which asks that which says that you're leaving and your answer might not be saved or something. Some certain kind of warning message will be shown. So in the exam, probably just everybody will submit only once. But even though my setting is to submit 100 times regardless, but when you do quiz, you can just do it like first two problem and you didn't have time to finish it. And so you want to go back to the quiz later in the day, then what you will do will be your answers are saved, but maybe you can just submit. And then when you come back again and you complete the quiz and then submit that again, then just your score will be updated in the gradebook. So when you submit unfinished quiz, the unfinished quiz score will emerge in the web courses as it has been. But if you finish it after that, later in the day or other day, then the website will update your score accordingly. So you don't have to feel bad about lower score when you didn't complete the quiz. So any question about how things are working about quiz and test? Okay, that's the fundamental change. And if you watch my short video clip about the exam 2, then you can get more information about how to prepare for the exam. let's go back to the lesson. What we have been doing is simplifying the expression. We have cosecant of x minus sine of x over cosine of x. In this expression, numerator contains two terms, so it becomes harder to manage it. So we want to separate that into two terms. So we write cosecant of x over cosine of x minus sine of x over cosine of x. Our strategy has been converting all terms into the sine and cosine related expression. So for the first one, we will write cosecant of x, which is a numerator, times 1 over denominator, cosine of x, minus sine of x over cosine of x. For the second one, we don't make any change because those are already sine and cosine. For the first term, we can rewrite that as 1 over sine of x times 1 over cosine of x minus sine of x over cosine of x. Now, all the expressions are related to sine and cosine. And then we think about the common denominator. Common denominator is sine times cosine. The first fraction is sine x times cosine x minus second one is sine over cosine x times the denominator is cosine and the common denominator is sine times cosine. So we have to multiply by sine x over sine x. Then we could make the denominator, both denominator as sine x times cosine of x. 1 minus sine times sine is sine squared of x. For the Pythagorean formula, that is cosine squared of x plus sine squared of x equals 1. So 1 minus sine squared of x equals cosine squared of x, right? I subtracted sine squared on both sides. Then the numerator is cosine times cosine, because that is cosine squared. Why did I express like this? Because I want to simplify and I want to see that easier. Sine x times cosine of x, those two will cancel each other. And then for this part, cosine over sine is cotangent of x. Any question? The next one is 1 plus sine of x over cosine of x plus cosine of x over 1 plus sine of x. So all the expressions are already sine and cosine, but we notice that the denominators are different, and common denominator is obtained by multiplying those two together. So 1 plus sine of x over cosine of x. The other fraction's denominator is 1 plus sine of x. So I would multiply that in the denominator, but I have to do the same in the numerator to keep the quantity the same. So the second one is cosine over 1 plus sine of x. And then cosine is missing, so I would multiply by cosine of x, but I have to do that to the numerator also. So that becomes cosine over cosine. We have common denominator, cosine of x times 1 plus sine of x. We want to expand this by using FOIL because those are multiplied. So that is 1 plus sine of x plus sine of x plus sine squared of x plus, from here we have cosine squared of x. So sine squared plus cosine squared equals 1. So we have 1 plus 1 equals 2, plus this one appears twice, so 2 sine x over cosine of x times 1 plus sine of x. The 2 is a common factor, so 2 open parenthesis 1 plus sine of x over cosine of x times 1 plus sine of x. So these two will cancel each other, and then we have 2 over cosine of x, and we have to simplify further without denominator. So we rewrite that as 2 times 1 over cosine of x. So that is 2 times, that is the secant of x. Any question? The type of problems we've been solving have been simplifying the given algebraic expression this time. The trigonometric identity is given, and we wanna verify it. So consequence is given, and we wanna verify. That is 1 over 1 minus sine squared of x equals 1 plus tangent squared of x. If you look at this problem, then what you see is on the right side, 1 plus tangent squared is secant squared. So that's involved to the Pythagorean identity, right? On the left side, again, you see something related to the Pythagorean identity because 1 minus sine squared of theta in the denominator can be re-expressed as cosine squared of x. And then 1 over cosine squared of x is secant squared of x. And it becomes a aha moment because secant squared equals 1 plus tangent squared. So if all the formulas are clear, then you can easily verify. Let's do that. 1 over 1 minus sine squared of x, that can be written as 1 over cosine squared of x. What I told you was sine squared of x plus cosine squared of x equals 1. We subtract sine on both sides, then we obtain cosine squared of x. That is secant squared of x. Why is that? Secant x is 1 over cosine of x. And that equals 1 plus tangent squared of x because of the Pythagorean identity. Any question? Second one is 1 minus cosine of x over sine of x, that equals sine of x over 1 plus cosine of x. On the left side, we have 1 minus cosine of x. The denominator is sine of x. On the right side, we have sine over 1 plus cosine of x. The denominators are different, right? So we have to transition from the left side to the right side, and denominators are so different. So the first attempt we can do is thinking about the common denominator. So we start on the left side and then we multiply by the denominator on the right side to the numerator and denominator for the common denominator, in the hope to change the denominator sign to 1 plus cosine of x by certain circumstance. So denominator becomes sine x times 1 plus cosine of x, and then we do distribution. So that becomes 1 plus cosine of x minus cosine of x minus cosine squared of x. So those two will cancel each other. The denominator is sine of x times 1 plus cosine of x. And of course, from here to here, I will use the Pythagorean formula. So 1 minus cosine squared of x is sine squared of x. I subtracted sine squared on both sides. Then, let me just write down one more line. So sine of x times sine of x over sine x times 1 plus cosine of x. So these two will cancel each other. And then that is sine of x over 1 plus cosine of x. Are you ready? The next problem is make the indicated trigonometric substitution in the given algebraic expression and simplify. Assume that the angle theta is in between 0 and pi over 2. The reason they're giving you this condition, angle is between 0 and pi over 2, is the angle is in quadrant 1. In quadrant 1, everything is positive. So in this problem, what we are supposed to do is when the problem is given with an algebraic expression, square root of x squared minus 1, when x is indicated as secant of theta, we have to do the substitution first. That means we replace x by secant theta in the given algebraic expression and then simplify. And so substitution first and simplify next. Let's do that. The given algebraic expression was x squared minus 1. Instead of x, I would write secant. So it becomes secant square root of theta minus 1. What we have to do is simplify. We know that 1 plus tangent square root of theta equals secant square root of theta. So we subtract 1 on both sides. Then we make secant square root of theta minus 1. And so what's under the square root is indeed tangent square root of theta. So we subtracted 1 on both sides. And then we have tangent of theta. We don't think about whether that is plus or minus tangent of theta because tangent is already positive, so we don't have to put minus sign in front of tangent so that we can make the whole thing positive because square root of something is positive number. Any question? Yeah. Yeah, so what I was saying was that I subtracted 1 on both sides, so those will cancel each other, and left side is tangent squared, and right side is secant squared minus 1. That is identical to this one. So instead of that one, I wrote tangent squared. Any other question? The second problem, the algebraic expression is given as a square root of x squared minus 16 over x, while the x is given as 4 secant of theta. We do substitution first, as indicated in the problem. Here, x squared equals 16 secant square root of x, each one's square. So 16 secant square root of x minus the second number was 16 over denominator was 4 secant of theta. Here we take out 16, open parenthesis, secant square root of x minus 1, close parenthesis, over 4 secant of theta. We know that 1 plus tangent square root of theta equals secant square root of theta. So as I did in the previous problem, we obtain tangent squared equals secant squared minus 1. So we replace secant squared minus 1 by tangent squared. So 16 tangent squared x over 4 secant of, I'm sorry, so I had to write theta, just sorry for this. X is secant of theta, so I had to write here theta, right? And then this one would be 4, square root of 16 is 4, and then square root of tangent squared is tangent, so tangent of theta over 4 secant of theta. So this 4 and 4 will cancel each other, and this fraction can be written as tangent of theta times 1 over secant of theta. And tangent is sine over cosine, so sine theta over cosine of theta times the next one is cosine of theta over 1. So those two will cancel each other, and we get sine of theta in the end. Any question?
Buster, could you please show the previous page one more time?
So that's it for 7.1. 7.2 is the last section we have to cover for the exam. So 7.2 is about addition and subtraction formulas. There are important formulas here. You will copy all of those. And then I will tell you the meaning of each formula and how to use it. Did you copy everything? Are you ready? So far, when you evaluate something, those had to be directly related to the 30, 60 90-degree triangle, or 45, 45, 90-degree triangle, directly or through the reference angle. In this section, what we want to do is we want to extend the type of angles we can evaluate without using calculator. Those angles will be expressed either with sum or difference of the well-known angle, such as 35, 40, 30 degree, 45, 60 degree, 90 degree, and so on. For example, the 30 degree and 45 degrees are well-known angle. And when we have 75 degree, we cannot evaluate sine or cosine or tangent with reference angle or any other method. But if we know addition and subtraction formula, then we will realize 75 degree is the sum of 30 degree and 45 degree. Therefore, if we use this formula, then we can evaluate the exact value of sine, cosine, tangent function without using calculator. So that's the purpose of this section. And let me explain what the meaning of each formula is. So I wrote plus or minus in the middle. That means just I wrote two formulas together. So angles are combined with some sign of the sum of S and T. That can be calculated as sine of S times sine of T plus cosine of S times cosine of T. So plus goes to plus and minus goes to minus. So sine of S minus T is calculated as sine of S times cosine of T. And the middle part is the difference of two angles. And then we think about the difference here. But in the cosine sum and difference formula, you will combine the same type of functions. Cosine will be combined with cosine and sine will be combined with sine. But in the middle part, when two angles are added, when we use the formula, we have to switch the sign. It'll be expressed as minus. And so plus will become minus and minus will become plus. For the tangent, for the numerator, it looks like a distribution. When we think about the sum of two angles, the numerator will be sum of two angles tangent values. But for denominator, if angles are added, then it'll be 1 minus tangent of S times tangent of T. Okay. So I think I explained what's in the chat. So it is like a plus minus will become minus plus, plus will become minus, minus will become plus in the denominator, and the numerator, the sign will be preserved. It looks like the distribution, even though that is not distribution of tangent. Those are the formulas. Indeed, you have to remember very clearly. But in the exam, I will give you the formula on the top of the page. But in the past, what I know is when students couldn't memorize the formulas, they tended not to be able to solve the problem, even with the formula given. They couldn't interpret the formula and they couldn't figure out the process. So the reason I give you the formula is because there is some subtlety in the middle part. Cosine switch the sign, but sine doesn't, and in the tangent, just a numerator, the sign in the middle part will be the same, but denominator changes. So there's some subtle part, and so the reason I'm giving you the formula is to verify rather than not remembering the formula. If you're planning to take a calculus course, then in calculus 2, you will use addition and subtraction formula in trigonometry. And they expect you already know all the sum and difference formula, and those formulas will not be given in the exam. So this formula will be used in the calculus, and in calculus, they don't explain it again, but they will, at the same time, they expect you to remember those formula. So you have to remember those formula, okay? Find the exact value. The first problem is a sine of 75 degrees. We want to combine the well-known angles. So I would list the well-known angles. Those are like 30 degree, 45 degree, 60 degree, 90 degree, and so on. We find that 30 and 45 can be added to make 75 degree. That's what I want to use. Sine of 75 degree can be rewritten as sine of 45 degree plus 30 degree. By using the formula, I can write that is sine of 45 degree times cosine of 30 degree plus cosine of 45 degree times sine of 30 degree. So that's just using the formula you wrote. So sine of 45 degree is square root of 2 over 2 times cosine of 30 degree is square root of 3 over 2 plus cosine of 45 degree is square root of 2 over 2 times sine of 30 degree is 1 over 2. The denominator is 4 and the numerator is square root of 6 plus square root of 2. So that's the final answer. Any question? The next problem is sine of 43 pi over 12. Or 43 pi over 12 looks pretty large, right? So I don't like the large fractions, so I want to reduce the fraction to evaluate the sine value. So I will use the coterminal angle. So what I will do will be I will subtract 2 pi. Then that is 43 pi over 12 minus 24 pi over 12. So that is 19 pi over 12. So what we are thinking about is coterminal angle. Because those two angles will have the same sine value, right? Now 19 pi over 12, I want to combine the angles, but fraction seems to be too large again. So I will subtract 2 pi again. 19 pi over 12 minus 2 pi is 19 pi over 12 minus 24 pi over 12. So that is minus 5 pi over 12. So those are again coterminal angles. Now I feel like those are small enough to manage. So instead of writing sine of 43 pi over 12, I would write sine of pi minus 5 pi over 12 instead. And then I don't like minus sign here. So what I want to do is I want to write minus in front of sine because sine is an odd function. Any questions so far? So we want to list the well-known angle. This time it should be with radian measure. So that becomes like pi over 2, pi over 3, pi over 4, pi over 6, and so on. Our problem is the denominator is 12. So we convert all of them into over 12. So the first one will become 6 pi over 12. The next one is 4 pi over 12, then 3 pi over 12, and 2 pi over 12, the equivalent fractions. When you look at the fractions, we know we can combine these two. this plus will make 5 pi over 12, and the corresponding, the simplest one is digit 2. So we calculate negative sine of 5 pi over 12. And then I want to write it as minus sine of pi over 4 plus pi over 6. So now I will use the sine formula, minus open parenthesis sine of pi over 4 times sine of pi over 6, no, cosine. We combine different ones, but the connection part is plus cosine of pi over 4 times sine of pi over 6. So it becomes minus open parenthesis. The first one is square root over 2 over 2. The second one is square root of 3 over 2. The cosine of pi over 4 is square root of 2 over 2 times sine of pi over 6 is 1 over 2. So we have common denominator 4 and minus in front. So minus is in front of fraction. The first term is square root of 6, and second term is square root of 2. When you type your answer in the WebAssign, be careful that so that you don't put minus in front of square root of 6. Type the minus first and then fraction. Of course, you can write like a minus square root of 6 minus square root of 2 over 4. If you want to put minus square root of 6 in front of minus in front of square root of 6. So denominator is 4 because those two are multiplied, and common denominator is 4 also. So when we multiply, we don't think of common denominator, we multiply directly. Do you have any other question? In the previous class, there was a technical issue at the beginning, so we spent pretty much time to fix the problem to start the class. So I'm ending the class here because we have to do the same thing. If you have any question, then come out and ask me question.